The fifth launch of the week launched on June 6, and it was the biggest launch of the week. Starship's fourth test flight. Welcome to our weekly cosmic rendezvous. Join us as we unveil the latest space updates, China's mysterious object release, India's groundbreaking 3D printed rocket engine launch, NASA's Hubble telescope resilience. In our astronomy segment, we delve into the intriguing impact of ozone on exoplanets and discover a weird planet defying a star's intense radiation to keep its atmosphere intact. Welcome to Cosmic Genesis. China's reusable space plane, named Shenlong, recently deployed an unidentified object into Earth's orbit. This experimental orbital plane, which has been in space for 168 days, was noticed by space activity tracker Jonathan McDowell on May 24. The new object has been designated as 59884, International Designator 2023-195G, by the U.S. Space Force Space Domain Awareness Teams. McDowell, an astronomer from the Harvard-Smithsonian Center for Astrophysics, speculated that the object could be a sub-satellite deployment or a piece of hardware released before the end of the mission. Another possibility is that the spaceplane released the object for maneuver tests related to proximity and recapture, similar to previous tests conducted during its second flight in 2022. The current mission of the reusable spaceplane began on December 14, 2023, when it was launched aboard a Long March 2F rocket from the Jiuquan Satellite Launch Center. Although China has maintained secrecy about the spacecraft, reports suggest that the mission involves verifying reusable technology and conducting space science experiments to support peaceful space utilization. During this mission, Shenlong has ejected multiple objects into orbit, including 6 mysterious objects emitting signals shortly after its December launch. The spacecraft has also performed orbit maneuvers. While details about Shenlong remain scarce, it is believed to be comparable in size and function to the U.S. Air Force's X-37B spaceplane, offering cost efficiency and potential for increased mission frequency. Agnikul Cosmos, an Indian space startup, achieved a significant milestone by successfully launching India's first 3D printed rocket engine on Thursday, May 30th. This breakthrough is expected to streamline the process of rocket manufacturing, leading to cost and time savings while advancing the country's capabilities in space exploration. Satyanarayanan Chakravarthi, associated with Agnikul Cosmos and an aerospace engineering professor at the Indian Institute of Technology in Madras, emphasized the unparalleled speed at which rockets can now be assembled due to this technological advancement. The recent launch marked India's second private rocket launch and showcased the use of a semi-cryogenic engine, a departure from traditional cryogenic engines. Semi-cryogenic engines, which use refined kerosene instead of liquid hydrogen, offer benefits such as reduced storage requirements and operational simplicity, enabling higher payload capacity and thrust. The rocket named Agniban Sorted, Suborbital Technology Demonstrator, completed its 5th attempt at the mission, successfully reaching an altitude of 5 miles, 8 kilometers, before landing in the Bay of Bengal. The startup confirmed that all mission objectives were achieved during this controlled vertical ascent flight. Srinath Ravichandran, the co-founder and CEO of Agnikul Cosmos, highlighted the dedication and effort invested by the team to make this achievement possible. The data collected from this test flight will be instrumental in the development of the startup's orbital launch vehicle, Agniban, expected to launch by early next year. Pawan Goenka, the chairman of the Indian National Space Promotion and Authorization Center, INSPACU, described the successful mission as a historic moment for India's space industry. He commended the role of young innovators and entrepreneurs in driving innovation with cutting-edge technologies, such as the world's first 3D printed semi-cryogenic engine, to transform India's space sector. The Indian Space Association, IPSA, stated that this achievement will enhance global confidence in India's private space industry, as reported by Reuters. Agnico Cosmos has significantly reduced the time required to manufacture a rocket engine to around 75 hours using their automated 3D printing technology. This process is notably faster compared to the conventional method, which typically takes 10 to 12 weeks to build a similar-sized rocket engine, according to the startup's co-founder and CEO Srinath Ravichandran, as reported by TechCrunch. In a similar vein, the Indian Space Research Organisation, ISRO, recently tested a 3D printed rocket engine that streamlined manufacturing by reducing the number of engine parts from 14 to just 1. This innovation not only led to savings in raw materials but also cut down the overall production time by 60%. These advancements in indigenous technology are poised to enhance India's launch capabilities as the country aims to conduct approximately 30 civil and commercial launches in a little over a year. India's ambitious space exploration plans include sending 3 astronauts on a 3-day mission to low Earth orbit in 2025, lunar missions by 2040, establishing an orbiting space station by 2035, and setting up a lunar base before 2050. Mission managers have initiated a switch to a backup control mode for the Hubble Space Telescope due to issues with one of its 3 remaining gyroscopes, crucial for precise targeting and tracking of celestial objects. This adjustment will allow the iconic observatory to continue operations with some limitations on observations, ensuring its functionality well into the 2030s, as confirmed by officials on Tuesday. Patrick Krauss, the Hubble project manager, expressed confidence in the telescope's continued success in conducting groundbreaking scientific research throughout the upcoming decade and into the 2030s. Meanwhile, Mark Clampin, Director of Astrophysics at NASA headquarters, announced that, for the time being, the proposed commercial mission to boost Hubble to a higher altitude using a SpaceX Crew Dragon spacecraft has been ruled out. The suggested altitude boost aimed to counteract the gradual effects of atmospheric drag, which gradually pulls spacecraft back towards Earth. Although billionaire Jared Isaacman, known for leading commercial space missions, proposed this idea to extend Hubble's operational lifespan, project managers clarified that the telescope is not at risk of re-entering Earth's atmosphere in the near future. Current projections indicate that Hubble will continue its mission in orbit at least until 2035, affording time to evaluate future options if necessary. While acknowledging the insights gained from assessing commercial capabilities for a potential reboost mission, Clampin emphasized the need for further evaluation to determine the balance between long-term scientific benefits and short-term risks associated with such an endeavor. The Hubble Space Telescope, launched in April 1990 aboard the Shuttle Discovery, overcame initial setbacks caused by a flawed mirror to become a symbol of scientific achievement. Despite its challenging beginnings, Hubble's story has been one of triumph, with repair missions transforming it from a national embarrassment to a global icon of scientific discovery. Engineers swiftly devised a solution to address Hubble's initial vision issues by creating a new camera with relay mirrors tailored to counteract the primary mirror's aberration. Additionally, the CoStar device was developed to direct corrected light to Hubble's various instruments. During a crucial servicing mission in December 1993, astronauts installed the new Wide-Field Planetary Camera 2 and CoStar, along with replacing Hubble's solar panels and other vital components. Subsequent servicing missions saw the installation of advanced instruments and the replacement of aging components like gyroscopes and fine guidance sensors. Gyroscopes play a pivotal role in Hubble's operations. Although the telescope was launched with 6 gyroscopes, only 3 are required for normal functioning. During the last servicing mission in 2009, all 6 gyroscopes were replaced, with newer units featuring improved designs to minimize risks. By Hubble's 30th anniversary in 2020, all 3 of the older model gyroscopes had failed, prompting operational challenges. To mitigate the impact of gyroscope failures, engineers had developed software enabling Hubble to operate with fewer gyroscopes. Ultimately, the decision was made to continue operations with just 1 gyroscope, optimizing the telescope's longevity while acknowledging reduced efficiency in scheduling science observations. Patrick Krauss emphasized the team's long-standing plan for single gyroscope operations, highlighting the need for a strategic approach to sustain Hubble's mission. Despite the operational adjustments, the telescope's ability to function with one gyroscope ensures its continued scientific contributions, albeit with a slight reduction in scheduling efficiency. Furthermore, operating in single gyroscope mode will result in slightly less precision in the telescope's movements and may introduce errors, impacting the flexibility in selecting observation targets in the sky simultaneously. However, over the course of a year, the telescope will have access to observe the entire sky. Another constraint of the one gyroscope mode is the inability to track targets closer than the orbit of Mars, although such observations were infrequent even when operating with 3 gyroscopes. Engineers are set to activate the one gyroscope control mode in the upcoming days, aiming to resume Hubble's scientific operations by the middle of the month. Despite the challenges, assessments indicate a high probability of maintaining at least one operational gyroscope through 2035, ensuring the telescope's continued functionality. While the James Webb Space Telescope advances space-based astronomy by delving deeper into space and time, Hubble remains a vital tool for astronomers, producing significant observations. The goal is to prolong Hubble's operations for as long as feasible to continue its legacy of groundbreaking discoveries in the field of astronomy. As the number of discovered exoplanets surpasses 5,200, astrobiologists are actively studying their atmospheres in search of potential signs of life. While it is possible that life in the universe could be based on different chemistry than Earth's, researchers often look to Earth's life forms as a reference point. For instance, the presence of ozone, formed through the photolysis of molecular oxygen, serves as an indicator of life on Earth. With the assistance of the James Webb Space Telescope, astronomers are focusing on exoplanets within the habitable zone of their stars to investigate the presence of ozone and its impact on their climates. Out of the identified exoplanets, 425 are located within their star's habitable zone, where conditions might be conducive to supporting life. Many of these Earth-like planets orbit M-dwarf stars, potentially experiencing tidal spin synchronization that could lead to significant differences in daytime and nighttime irradiation, influencing atmospheric dynamics. The unique atmospheric dynamics, including strong convection and the formation of Rossby waves, could affect the distribution of chemicals like ozone. While molecular oxygen on Earth is a sign of life due to its production through photosynthesis, the presence of ozone indicates biological processes. However, on exoplanets, the presence of molecular oxygen might have non-biological origins depending on the balance of near and far ultraviolet radiation. Recent research published by Paolo De Luca and colleagues on Proxima Centauri b, an Earth-sized exoplanet orbiting the red dwarf star Proxima Centauri, highlights the impact of climate modeling, including interactive ozone, on understanding tidally locked, Earth-like exoplanets. Their simulations using the James Webb Telescope show that incorporating ozone globally raises stratospheric temperatures, leading to regional variations in surface temperature and a reduction in temperature contrasts between the day and night sides of the planet. The team's objective was not to detect life on exoplanets but rather to enhance their comprehension of exoplanet atmospheres by utilizing the James Webb Space Telescope. Their focus was on studying the processes involved in atmospheric ozone formation and its effects on temperatures. The discovery of a rare exoplanet known as Phoenix challenges scientists' understanding of planetary evolution in extreme environments. Despite its proximity to a red giant star that should have stripped it down to rock, Phoenix surprisingly developed a puffy atmosphere instead, prompting researchers to reconsider conventional theories about how planets age and perish. Named TIC 365102760b, this new planet falls into the category of hot Neptunes, resembling frozen giants like Neptune but orbiting much closer to their host stars, resulting in scorching temperatures. Despite being smaller, older, and hotter than expected, Phoenix maintains a larger, less dense atmosphere than anticipated, raising questions about how it retained this atmosphere in such a harsh environment. With a size 6.2 times that of Earth and a rapid 4.2-day orbit around its star, Phoenix is positioned about 6 times closer to its star than Mercury is to the Sun. Scientists believe that despite its extreme conditions, the planet's atmosphere loss has been slower than predicted, with an estimated lifespan of less than 100 million years before it spirals into its giant star. This peculiar exoplanet, the smallest found orbiting a red giant, defies expectations due to its unusual characteristics. Researchers are puzzled by why Phoenix, unlike smaller, denser, hot Neptunes, has not shed its atmosphere in a more extreme environment. To unravel these mysteries, Sam Grunblatt and his team refined data from NASA's Transiting Exoplanet Survey satellite using a novel method. By combining satellite data with observations from the W.M. Keck Observatory in Hawaii, which track star wobbles caused by orbiting planets, they gained valuable insights into low-density planets like Phoenix. The discoveries could enhance scientists' understanding of the potential evolution of atmospheres similar to Earth's, according to Grunblatt. With the Sun's projected transformation into a red giant star in a few billion years, engulfing Earth and the inner planets, there is much to learn about the late-stage evolution of planetary systems. Grunblatt emphasized the limited knowledge about the final stages of planetary system evolution and how Earth's atmosphere may not follow expected patterns. Puffy planets, characterized by their lower density compared to any planet in our solar system, are typically made up of gases, ice, or lighter materials, making them uncommon, with only about 1% of stars believed to host them. Discovering exoplanets like Phoenix poses a challenge due to their smaller size, making them harder to detect compared to larger, denser planets. Grunblatt's team aims to identify more of these elusive small worlds and has already identified a dozen potential candidates using their innovative approach. Grunblatt stressed the ongoing need to deepen our understanding of how planetary atmospheres evolve over time, highlighting the journey ahead in unraveling these mysteries. The first launch of the week launched on June 4th. SpaceX Starlink 8-5 mission involved the successful launch of 20 Starlink satellites from Pad 40 at Cape Canaveral Space Force Station. This launch marked the 14th anniversary of the Falcon 9 family of rockets. This launch included 13 satellites capable of providing direct-to-cell service, expanding the capabilities of the Starlink Internet satellite constellation. The first stage booster supporting this mission was identified by tail number B1067 in the SpaceX fleet and marked its 20th flight. This mission further advances SpaceX's goal of expanding global internet coverage through its innovative Starlink satellite network. The second launch of the week launched on June 5th. Rocket Lab's Electron launched the Pre-Fire and ICE mission. Pre-Fire mission consists of two 6U CubeSats with a baseline mission length of 10 months. It aims to close a gap in understanding how much of Earth's heat is lost to space, especially from the Arctic and Antarctica. This mission will provide valuable data for climate monitoring and understanding Earth's heat radiation patterns. The ICE mission is part of NASA's Pre-Fire mission and consists of two shoebox-sized cube satellites. These satellites will measure the amount of heat Earth radiates into space from the Earth's poles. The data collected from the ICE mission will contribute to climate and ice models, offering insights into how a warming world will impact sea levels and ice formations. Both missions are crucial for advancing our understanding of Earth's climate and heat radiation processes. The third launch of the week launched on June 5th. China's Series 1 rocket launched the mission dubbed Love on Top. The mission aimed to achieve specific objectives related to space exploration and technology advancement. This mission represents another exciting step in the field of space exploration. The fourth launch of the week launched on June 5th was the long-awaited Starliner Crew space transportation mission. With two astronauts aboard, Sunita Williams and Barry Wilmore, transported to the International Space Station.
Yeah, we are thrilled as well. I'm not sure we could have gotten a better welcome. I mean, we had music, we had Matt was dancing. It was great.
This mission will mark the first crewed launch of the Atlas V rocket, which also marks the 100th launch of the rocket, which is nearing retirement. The fifth launch of the week launched on June 6th, and it was the biggest launch of the week. Starship's fourth test flight. During the fourth test flight of SpaceX's Starship, several significant milestones were achieved, bringing us closer to a future of rapidly reusable space transportation. The mission focused on demonstrating the capability to return and reuse the Starship and its Super Heavy booster. Some of the key achievements of this test flight include the successful soft landing of the Starship's Super Heavy booster, marking a crucial step towards reusability. Additionally, the mission accomplished the first re-entry and soft splashdown of the Starship, further advancing SpaceX's goal of creating a fully reusable spacecraft. The data gathered from this flight will play a vital role in driving future developments and innovations in space exploration. The sixth launch of the week launched on June 8. SpaceX Starlink 10-1 mission involved the successful launch of a batch of Starlink V2 mini satellites for their second-generation high-speed low-Earth orbit internet satellite constellation. The liftoff took place at Space Launch Complex 40, adding another 22 satellites to the massive constellation consisting of more than 6,000 active satellites in low Earth orbit. The first stage booster supporting this mission, identified by tail number B1069 in the SpaceX fleet, was launched for the 16th time. The sixth launch of the week launched on June 8. SpaceX Starlink 8-8 mission involved the successful launch of 20 Starlink satellites, adding more satellites to the low Earth orbit constellation. This mission included 13 satellites capable of providing direct-to-cell service, enhancing the capabilities of the Starlink Internet satellite network. The liftoff took place from Pad 40 at Cape Canaveral Space Force Station. The first stage booster supporting this mission was identified by tail number B1068 in the SpaceX fleet, marking its 21st flight. The booster successfully landed after deployment, showcasing the reusability of SpaceX's Falcon 9 rockets. The seventh and last launch of the week, also launched on June 8, Spaceship Two Galactic 07 mission launch by Virgin Galactic marked the final commercial flight of VSS Unity. This mission, also known as Galactic 07, reached an impressive altitude of 54.4 miles, 87.5 kilometers, representing the seventh commercial spaceflight conducted by Virgin Galactic. The launch window for Galactic 07 opened on Saturday, June 8, showcasing the company's commitment to advancing commercial space travel.